Okay, today's topic is terminal velocity. And it is the continuation with the forces and motion. What is terminal velocity? To understand the terminal velocity, imagine that you have an object. Here it is, a ball. You have this ball. You lift the ball above the ground, and you dropped it. Now, when you drop the ball, what will be the initial velocity? Remember that when you drop something, the initial velocity of the object is 0, and then it starts increasing gradually. So let's say the initial velocity is 0. Initial acceleration will be equal to the gravitational acceleration that nowadays you are taking 9.8 meter per second square. Now talk about the forces. What force that acting on the ball, which is taking the ball downward, that is weight of this ball. So the weight of the ball is acting downward, and the upward force is air resistant. But since we discussed that the initial velocity is 0, and in the absence of any speed velocity, the air resistance will also be 0, because we discussed earlier that air resistance depends on the speed. More the speed, more will be the air resistance. So since the speed is 0 right now, so the air resistance will also be 0. So in the absence of any of these opposing forces, the only force acting on the ball is weight of the object. So the net force acting on the ball, F, is equal to weight. W stands for weight here. Okay, so ball starts falling down gradually. Let's suppose the ball reaches to the next level here. At this point, the speed is not 0, now the speed has increased. Now since the ball has gained some speed, so now the air resistance will not be 0 as well, so air resistance will also increases. Let's compare the forces at this position. Downward force is the weight, and weight is same W, but now it has some air resistance. Let's consider R is the air resistance. R is the air resistance. So in this case, the net force acting will be F is equal to W minus R, because the resistance and weight are acting oppositely. So when the two forces acting in opposite direction, the net force can be found out by subtracting the two forces. Now since the net force is less, now we can say that acceleration is also less than. Remember that acceleration, according to the Newton's second law, acceleration is directly proportional to the net force. More the net force, more will be the acceleration. So since now the net force is reducing, so that the acceleration as well. Now let's move to the next position here. At this position number 3, we assume that at this point, since now point to be noted, I already have discussed that air resistance increases with the speed. More the speed, more will be the air resistance. Let me write it here, this fact as well, that air resistance R is directly proportional to speed. More speed, more resistance. Less speed, less resistance. Zero speed, zero resistance. Now, since the ball is continuously gaining the speed, so along with the speed, the air resistance also continuously increasing. So don't you think there will be a point that the air resistance increases so much that it becomes equal to the weight of the object? Remember that resistance is also a force as well as the weight. So let's suppose that at position number 3, let me name this position number 1, position 2, position number 3. So position number 3 is the position where resistance increases so much that it becomes equal to the weight. Now what happened when resistance and weights both are equal? Weight is acting downward and resistance is acting upward. Be careful when you're drawing the arrows, when you say that the both are equal, so try to make the both arrows equal as well. Not necessary that you measure the two things, but what you can do, try to make equal. Okay, so when I say that resistance and weight are equal for position number 3, weight is equal to the resistance. When resistance and weight are equal, so at this position, can I say that the net force will be equal to W minus R, and this will be equal to 0, because weight and resistance are equal in values. So the net force will be 0. Now look at this, what we have discussed earlier, that acceleration is directly proportional to the force. More force, more acceleration. Less force, less acceleration. And zero net force, zero acceleration. So when resistance and weight both becomes equal, at this position the net force will be 0. And when net force is 0, the the acceleration will also be 0. Now what is meant by zero acceleration? Zero acceleration means acceleration is equal to 0. When acceleration is 0, what is acceleration? Acceleration is change in velocity in a unit time. When I say that acceleration is 0, it means there is no change in velocity. Once I say that there is no change in velocity, it means that object is moving with uniform velocity. And this uniform velocity is called terminal velocity. So at this position, velocity will be uniform and is called terminal velocity. And after that, the object will continue to move with the uniform velocity, no change in the velocity, and will be called terminal velocity. So if you wish to write the definition of the terminal velocity, what we can write? Terminal velocity when the forces acting on a moving object. Remember, moving object. becomes balanced. The object the object will start moving with uniform velocity. And this uniform velocity is called terminal velocity. Understand? It is very important topic. Please pay attention to this one. A lot of question comes regarding terminal velocity. At this point, remember that terminal velocity is not limited to an object which is falling downward. A car moving on the road can also achieve the terminal velocity. How? If a car moving on the road trying to make a car for you. Okay, let's suppose the car is moving this way. So this arrow is called engine force or driving force. The back foot force that acting on the car will be the resistive forces that included air resistance and resistance between tires and roads as well. So R is the resistance, total resistive forces. When I say the driving force will be Fd and R is the resistance, when the car speeds so much that forward force, driving force becomes equal to the resistance, the net force will be 0. When net force 0, the acceleration will also be 0 and velocity will be uniform. And this uniform velocity will be called terminal velocity. And that is the reason that if you press the accelerator, car will initially speeds up, but after some time, although you are applying the same force, the car will not further speed up, but it start to move with constant speed, because at this point the engine force and resistive forces are equal to each other. If you want to increase the velocity, you want to produce the acceleration, you have to push accelerator more forward to produce more driving force, so that your driving force may be more than the resistive forces. So you have to increase the forces to continue create the acceleration. Okay, here is one point. You must have observed that if you have a coin, if you have a coin here, this is a coin, and you have a small piece of tissue paper or a feather, whatever, very lightweight. What happened when you drop the two things to the ground? What thing fall first? Definitely the coin will fall first. And the paper will fall slowly and before after the coin. The reason, because since the paper is very uh, has very lightweight and its area is more as compared to the weight, so paper will immediately started to move with terminal velocity because the resistive forces instantaneously becomes equal to the weight of the paper. So paper will start falling with terminal velocity, and when it once an object gain the terminal velocity, there will be no further increase in its velocity. So paper will start moving slowly, while the coin, since the coin weight is much larger than the paper, the coin will continue to accelerate downward. So that is why coin will move faster and hit the ground quickly. What happened if you do the same experiment in a vacuum? A vacuum is the place where there is no air resistance. Or the question mostly comes that you do the experiment on the surface of the moon. Remember, there is no atmosphere, no air in the moon, but moon do have the gravity, although it is less than the earth, but it do have. So if you do this experiment on the moon or in a chamber where there is a vacuum, what will happen? In vacuum, both will fall at the same time, because in the absence of air resistance, no none of these objects will gain the terminal velocity. So both will fall at the same time to the ground. I'm writing here, please note down. In the absence of air resistance, means in vacuum or in any planet or on the moon where there is no atmosphere. If you do repeat this experiment, both will fall at the same time. Okay, now let's talk about the graph of the terminal velocity. Very important thing. Should not forget the graph of the terminal velocity. Very important. Now, if on the y-axis I take speed or velocity, and on x-axis I took time. So V, remember V for speed or velocity and T for time. So graph of the terminal velocity will be like this. This is a typical terminal velocity graph. Now, remember that what is happening if I mark the position, different position. Let me call this initial position, let me call A. This is B and this is C. What is happening between A and B? You can clearly observe that graph is bending towards the time. So gradient is decreasing, and what I told you, the gradient of the speed time graph represents the acceleration. So what is happening between A to B? The acceleration is continuously decreasing. At B, acceleration becomes zero. At B, acceleration becomes zero. And since that there is no acceleration at B, so after B, between B to C, object is moving with zero acceleration or with uniform velocity, and this uniform velocity is called terminal velocity. So the section of the graph where graph has a straight line will representing will represent the terminal velocity. If you draw the same graph for an object which is falling in a liquid, remember that liquid has more resistance than the air. So for the liquid, what type of graph you are expecting? Let me draw both of the graph. If this is the graph of an object falling through or moving through air, so this will be the graph of an object falling through liquid. Why? Because liquid can offer more resistance. So object will gain terminal velocity more quickly. Okay, so the value of the terminal velocity of the liquid in the liquid will be less than the air. So I hope you understand the terminal velocity. Later we will be discussing about the motion of the parachutist. Take care.